In this video, I'm going to work out a solution to the questions in the study guide. First question, the null and alternative hypotheses are given. Determine whether the test is left, right, or two-tailed, and what parameter is being tested. So since you see in H1, P is greater than 0.6, a greater sign means it's a right-tail test. And what population parameter are testing? We're testing P, which is called population proportion. Okay, so we're going to go to question 2 now. 3 years ago, the mean price of an existing single-family home was $243,748. The real estate broker believed that existing home prices in her neighborhood are lower. Lower means less than $243,778. So we need, so you will just use less here, and then you will put the amount, which is $243,748, and same amount should be in the null hypothesis. And definitely we're testing the mean here because it's an amount, and in the null, as you know, it's always equal, and then you put equal there. Now he's asking you what would define a type 1 error. Type 1 error by definition is the probability of rejecting the null hypothesis when it is true. So you're rejecting something that is correct. So you can see D is going to be the correct answer. The broker rejects the hypothesis that the mean price is $243,748 when it is actually true. Which of the following is type 2 error? Type 2 is the probability of failing to reject a null hypothesis when it is false. So you have to look for where it says fail to reject the null hypothesis. And if you look at D, the broker fails to reject the hypothesis that the mean price is 240 when the true mean price is not 243, it's less. So that would be D. Okay. Next question. So suppose the null hypothesis is rejected. What would you say? 3 years ago, the mean price of a single family home was $243,750. A real estate broker believes that the mean price has increased since then. So the null and the alternative hypothesis will be, the null will be the mean equals 243,750, and the alternative will be the mean is greater than 243,750. So if you reject the null hypothesis, you support the alternative. So you say there is sufficient evidence to conclude that the mean price has increased, which is going to be B. Okay, now we're going to go to the next question 4. The standard deviation in the pressure required to open a certain valve is known to be sigma equal 1.3 psi. Due to changes in the manufacturing process, the quality control manager feels that the pressure variety has increased, and the null hypothesis was not rejected. So, if you don't reject the null hypothesis, then you don't support the alternative hypothesis. So, if the null hypothesis is not rejected, that means the variability probably did not increase. So you will say there is not sufficient evidence that the standard deviation in the pressure required to open a certain valve has increased. So that would be E here. Okay. Next question. Oh, that was 4. We're going to 5 now. Put the following steps in the hypothesis testing in the correct order. So collect evidence, sample data to test the statement, analyze the data to assess the plausibility of the statement, make a statement regarding the nature of the population. So let's show you how to do that. So first of all, you make a statement. What is it that you want to do? Then collect evidence, and then you analyze the data. Okay, next question. According to a report, the mean monthly cell phone bill was 48.053 years ago. Research suspect that the mean monthly cell phone is higher. So the mean will be equal and the mean will be greater here. Higher means the greater. Just use the greater sign. All right. In a study of cell phone usage and brain hemispheric dominance, an research survey was emailed to 6,988 subjects randomly selected from an online group involved with ears. There was 1,324 surveys returned. Use a 1% significance level to test the claim that the return rate is less than 20%. So we need to test that P is less than 20%. That would be A. And now this would be a one proportion Z test. So I'm going to show you how to use a calculator to do this. You just go to stat and you go to tests and you go to proportion test. Oops, sorry. So stat again, tests, one proportion Z test. That's the test for the proportion. Okay, what is the value that we're testing against? It's 0.2, so just enter 0.2. And then you go to X, how many successes are there? So out of the sample of 6,988, 1324 returned the survey, so it's 1324. And N will be 6,988. And we are testing that P is less than. So here you pick the alternative sign. Very important to understand that. That's the alternative sign. And then you can hit calculate. So Z will be negative 2.20. P-value is 0.0139. And we're testing against 0.01. So this p-value is bigger than 0.01. Because it's bigger than 0.01, you will fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you don't support the claim. So you say there is not enough evidence to support the claim that the return rate is less than 20%. Next question. Okay, for this one, test the hypothesis using the p-value approach. So first of all, it's asking us to check the conditions of the test. N is 200, P0 you use 0.6. So if you multiply 200 times 0.6 times 1 minus 0.6, would you get a number bigger than 10? Yes, the answer is yes. So the conditions of the test are met. Now he wants us to find the p-value. So you just go to one prop Z test, and P0 you put 0.6, X is 135, N is 200. You choose the greater than sign from the alternative hypothesis and you hit calculate. And the p-value is 0.01519 or 0.0152 or 3 decimal places, so it will be 0.015. And what's alpha? 0.1. That's less than 0.1. In this case, you reject the null hypothesis because the p-value is less than what? Alpha. Next question. So some have argued that the following darts at the stock pages to decide which company to invest in could be a successful stock picking strategy. Suppose a researcher decides to test this theory and randomly choose 250 companies to invest in. After 1 year, 135 of the companies were considered winners. So N is 250 and X is 135. That is, they outperform other companies the same investment. To assess whether the dart picking strategy resulted in a majority of winners, the researcher tested HO P is 0.5 versus H1P greater than 0.5, obtain a p-value of 0.1030. He wants you to explain what the p-value means here. So 0.1030 means like 10%, about 10 out of 100. So you can choose about 10. It means about 10 in 100 samples will give a sample proportion as high or higher than the one obtained if we can assume that the null hypothesis is true. So that will be A. The p-value is 0.1030 and alpha is 0.1. That's bigger than alpha, so we fail to reject the null hypothesis. So because the p-value is large, we don't reject the null hypothesis. There is not sufficient evidence to conclude that dart picking strategy result in a majority of winners. Okay, in a previous poll, 34% of adults with children under age of 18 reported their family ate dinner together 7 nights a week. Suppose that in a more recent poll, 377 of 1,107 adults with children under age 18 reported their family ate dinner together 7 nights a week. Is there sufficient evidence of proportion with children who ate dinner 7 nights a week has decreased? So decrease means less than 34%. First of all, we need to verify the conditions of the test. So that should be greater than 10. You check it. So if you take n, which is 1,175, guys, multiply by 0.34, and 1 minus 0.34 is going to give you a number bigger than 10. And the sample size is less than 5% of the population. And the sample is given to be random. It should be random. Okay. Or can be reasonably assumed to be random, of course. If he doesn't say it, so just assume it is random. Then the requirement of the test and hypotheses are satisfied. Okay, what would be the null and the alternative? P equals, remember the null is always the equal sign, 0.34. And H1 will be P greater, does it say decrease, so less than 0.34. Okay, how do you perform the test? I'm going to show you the calculator. Okay, so you go to prop z test, so p0 0.34, you put the value of x. Well, actually, I made a mistake here. And x is 377, and n is the larger number. Otherwise, the calculator will not process this. 1175. And then we need less than sign, and then hit calculate. And z is negative 1.39, p-value is 0.0829. And let's see what alpha is. 0.05, this is bigger than alpha. You fail to reject the null hypothesis. And then you conclude that there is not sufficient evidence to support the claim. So no, there is not sufficient evidence because the p-value is greater than the level of significance. Therefore, we don't reject the null hypothesis. Okay, number 12, a college entrance exam company determined a score of 23 on the math portion of the exam suggests students is ready for college level math. To achieve this goal, a company recommends the students take a core curriculum of math courses in high school. So we have a random sample of 150 students who completed this course. Set course resulted in a mean, that's the sample mean, X bar 23.6 on the college entrance exam with a standard deviation 3.8. Do the results suggest that the students who complete the core curriculum are ready to take a college level mathematics? Okay, so they said any score of 23 or higher would mean that the students are ready. So so then the claim will be the mean is greater than 24, and the null hypothesis will be mean equals 23. Conditions of the test: population is normally distributed or sample size more than 30. So we have the sample size more than 30. The students were randomly sampled, and the students' test score are independent of each other. How do you find the p-value, guys? Here you just do a t-test. So you go to stat. You can do that in StatCrunch. You go to stat and t-stat, and then you perform a t-test with summary, not with data. So here we don't have data, so I'm going to go to stats, which means summary right there. Okay, we're testing against 23. X bar, he says, which is the sample mean, 23.6. S, the standard deviation was what? 3.8. And the sample size is 150. That's a large sample size. and we test that the mean is greater than 23. Oops. Sorry about that. Enter. And now if I hit calculate, so t is 1.93, and look at the p-value 0.0275. Here you go. If you round it to 3 decimal places, will be 0.08. And what's the decision? Alpha is what? 0.05. That's less than alpha. We reject the null hypothesis and support the claim. So you conclude that there is enough evidence at the 5% level of significance to support the claim that the students who complete the core curriculum are ready for college level mathematics. A credit score is used by credit agency such as mortgage company and banks to assess the credit worthiness of individuals. Values range from 300 to 850 with a credit score of over 700 considered to be quality credit risk. According to a survey, the mean credit score is 709.8. A credit analyst wondered whether high-income individual income in excess of 100,000 had higher credit scores, so mean more than 709.8. So we need to test it. We collect a sample of 44, found the sample mean credit score to be 720.4 with a standard deviation of 84.9. Conduct the appropriate test to determine if high income have higher credit score. So higher guys means more. It's a t-test. So you're gonna run the calculator again. So you go to stat, t-test, and you are testing against the number 709. I need to move this a little bit. 0.8. Then X bar, what was X bar? 720.4. Then we need the standard deviation, which is 84.9. That's a huge. And the sample size is 44. And we're testing if the mean is greater than. So this is where you pick the alternative sign from here, not the claim, the alternative sign. And you get t to be 0.83 if you round to 2 decimal places. And look at the p-value, is huge, 0.2060. So you're gonna fail to reject the null hypothesis. So you fail to reject the null hypothesis, and you conclude that you don't have sufficient evidence to support the claim. So for this one, guys, I'm going to show you how to use the StatCrunch to do it. A golf association required a golf ball had a diameter of 1.68 to determine golf ball conform to the standard. A random sample of golf was selected. The diameter are shown in the table. Do the golf balls conform to the standards? Use alpha equal 0.01. So just click here and go to StatCrunch, open in StatCrunch. You go to stat, tstat, one sample with data, select your data set, go to the null hypothesis. We're testing against 1.68. That should be not equal because that's what we're doing. Hit compute, and you get the test statistic and the p-value. And look, guys, the p-value is huge. So it's 0.4315. And just go back. The p-value is bigger than 0.10, fail to reject the null hypothesis. And if you fail to reject the null hypothesis, then the null hypothesis probably is okay. So you say there is not sufficient evidence to reject, the claim that the golf balls conform to the standards, or what he says here, to conclude the golf do not conform to the association standards. We're saying we can't reject that they don't conform. They do conform.